Hello students, we have already discussed about the introduction of integration. Now today here I will discuss about the methods of integration. There are so many methods of integration like integration by substitution method, integration by trigonometric functions, integration by partial fractions, integration by parts, integration by algebraic functions, integration by irrational functions, and some special type of integrations. Now here we will discuss first the method of integration by using substitution method. By integration by substitution method. So first of all we will take this method, that is integration by substitution method. What is that? What is this method? If the integrand is not a derivative of a simple function, then the corresponding integrals cannot be found directly. In such cases, the integral of complex problems, in such cases, or such functions where we will not evaluate the integral of that function directly, we will use this method, that is integration by substitution method. I will clear you this method by using a simple example, that is if we have to integrate 2x divided by 1 plus x square. Here, as we know that 2x divided by 1 plus x square is not directly the integrand of any function. Thus we here will apply the method by substitution method. Now the first step we will do here, we will put 1 plus x square is equal to t. Why? Because we know that the differentiation of 1 plus x square is 2x. That is why I put here 1 plus x square is equal to t. I again repeat, here I put 1 plus x square is equal to t, as we know that the differentiation of 1 plus x square is equal to 2x. That is why I put here 1 plus x square is equal to t. So here we will differentiate this with respect to x. Differentiate with respect to x, we get 2x is equal to dt divided by dx. Now I am changing this function that is in the form of x in terms of t. I am changing variable x to t, so that here we will find the value of dx. So dx is equal to dt divided by 2x. Now putting these values, that is the value of dx and 1 plus x square in this main function, what will we get? Integration of 2x divided by 1 plus x square dx is equal to integration of 2x divided by, what is the 1 plus x square? We will write here t, and dx we will write here dt divided by 2x. This 2x cancelled. So integration of this will become 1 by t dt. As we know that from the previous lecture that integration of 1 by x dx is equal to log of modulus of x. In the same way here, if we integrate 1 by t with respect to t, we will get log of modulus of t plus c. But we have the original function is in terms of x, so here we will replace the value of t, that is 1 plus x square. So what will we get log of 1 plus x square plus c. Hence we can say the integration of 2x divided by 1 plus x square dx is log of modulus of 1 plus x square plus c. So this is the simple example how to solve such type of functions by using substitution method. Let's take another example. Integrate 1 divided by x plus x log x. First we will write this function as integral of 1 divided by, take x as a common, that is x 1 plus log x dx. Now we have to solve this integral by using substitution method. Now if we see here 1 plus log x, the differentiation of log x is 1 by x. As we know that the differentiation of 1 plus log x is again 1 by x. Now we will put here 1 plus log x is equal to t. Why? Because we know that the differentiation of 1 plus log x is 1 by x, and this x will be cancelled here. So differentiate both sides with respect to x. We will get 1 divided by x is equal to dt divided by dx, which implies dx is equal to x dt. So substituting these values in this original equation, what will we get? Integration of 1 divided by x, and 1 plus log x is equal to t, so we will write here t, and dx is equal to x dt. So this x and this x will be cancelled here. So what will we get? Integration of 1 divided by t dt. Again, as we know that integration of 1 by t is log of modulus of t plus c, which implies log of, what is the value of t, and t is equal to 1 plus log x. So replacing the value of t, we will get log of modulus of 1 plus log x plus c. This will be the solution of this equation, or this will be the value of this integral. Let's take another few examples related to the same concept, that is integrate e raised to power 10 inverse of x divided by 1 plus x square. Now we have to solve this integral by using substitution method. First we will check what we have to substitute here. As we know that the differentiation of tan inverse of x is 1 divided by 1 plus x square. So we will put here that tan inverse of x is equal to t. So what is the differentiation of tan inverse of x? As we know that the differentiation of tan inverse of x is 1 divided by 1 plus x square, which is equal to dt divided by dx. So here dx will be 1 plus x square into dt. So substituting these values in the original equation, we will get integration of e raised to power t divided by 1 plus x square into, what is the value of dx? Dx is 1 plus x square into dt. This will be cancelled here. So which is equal to integration of e raised to power t dt. As we know that from the previous lecture, integration of e raised to power x dx is equal to e raised to power x plus c. Therefore, integration of e raised to power t dt is equal to e raised to power t plus c. Replacing the value of t, we will get e raised to power, what is the value of t? T is tan inverse of x. We will get e raised to power tan inverse of x plus c. So this will be the integral of this question. Now let's take the example number 4 related to the same concept. Integrate sin inverse of x divided by square root of 1 minus x square dx. We have to integrate this function. Now, if we put square root of 1 minus x square is equal to t, as we know that there is no differentiation the square root of 1 minus x square, so that we will get sin inverse of x. Here we will put sin inverse of x is equal to t, because we know that the differentiation of sin inverse of x is, as we know that the differentiation of sin inverse of x is 1 divided by square root of 1 minus x square. So it is better option for us, because as we know that the differentiation of sin inverse of x is this. So we will put here, put sin inverse of x is equal to t. So the differentiation of sin inverse of x is 1 divided by square root of 1 minus x square, that is equal to dt by dx, and dx will be square root of 1 minus x square into dt. Now substituting these values in the original function, we get here integral of sin inverse of x. We will write here t instead of sin inverse of x, and divide by root of 1 minus x square, and dx is equal to this root of 1 minus x square into dt. Here this will be cancelled, so we will get integration of t dt. So as we know that integration of x dx is or integration of x raised to power n dx is x raised to power n plus 1 divided by n plus 1 plus c. In the same way, we will get here integration of t dt is t square by 2 plus c. So replacing the value of t, what is the t? T is sin inverse of x. Sin inverse of x power 2 divided by 2 plus c. This will be the integral of this function. Let us do another question. Integrate x cube sin of tan inverse of x raised to power 4 divided by 1 plus x raised to power 8 dx. So first of all, we will select here what we have to substitute. We need x cube, we need 1 plus x raised to power 8. Now, if we put tan inverse of x raised to power 4 is equal to t, as we know that, first of all, as we know that the differentiation of tan inverse of x is 1 divided by 1 plus this x square, that is theta square, into internal differentiation of x is 1. Now if we have to differentiate tan inverse of x square, so its differentiation will be same as 1 divided by 1 plus theta square. Here theta is x square whole square. Here is x, we write here x square, here is x square. We write here x square whole square. Internal differentiation of x square is 2x. Also, if we have to differentiate tan inverse of x raised to power 4, in the same way, we will get 1 divided by 1 plus theta square, x raised to power 4 whole square into, what is the differentiation of x raised to power 4? That is 4x cube. Now, this is equal to 4x cube divided by 1 plus x raised to power 8. Now, if we see here the differentiation of tan inverse of x raised to power 4 is 4x cube, we need here x cube and divide by 1 plus x raised to power 8. So, here is also 1 plus x raised to power 8. So, this gives me the better choice to put or to substitute tan inverse of x raised to power 4 is equal to t. Now, we will substitute here or put tan inverse of x raised to power 4 is equal to t. So, what will be the differentiation of this? Here we have already found the differentiation of tan inverse of x raised to power 4, that is 1 divided by 1 plus x raised to power 8 into internal differentiation of x raised to power 4, that is 4x cube dt divided by dx. So, the value of the dx will be, dx is equal to 1 plus x power 8 dt divided by 4x cube. So, substituting these values, that is the value of the t, the value of the tan inverse of x raised to power 4 and the value of dx in the original equation, what will we get? So, integration will be integral of, this is x cube. First of all, we will write here x cube and sin here, and here is the tan inverse of x raised to power 4. Instead of tan inverse of x raised to power 4 here, I will write here t and divided by 1 plus x raised to power 8. So, we will write here 1 plus x raised to power 8 into, and dx, the value of the dx will be this 1 plus x raised to power 8 divided by 4x cube into dt. So, 4x cube, x cube and x cube will be cancelled here, and 1 plus x raised to power 8, 1 plus x raised to power 8 will be cancelled. What will we get? We get here integration of, this is sin t dt. So, integration of sin t is cos t plus c. So, replacing the value of t, that is this, we get here cos of, the value of t is tan inverse of x raised to power 4 plus c. So, this will be the integral of this question. The next question is integration of cos of square root of x divided by root x dx. Now, we have to integrate this function. So, we have to, first of all, we have to choose what will we substitute. So, it is the simple, if we substitute root x is equal to t. Why? Because we know that the differentiation of root x is 1 divided by 2 root x. As we know that the differentiation of root x is 1 divided by 2 root x. So, here we need root of root x. So, this gives me the best option to choose root x is equal to t. Now, we will put here, root x is equal to t. So, the differentiation of root x will be 1 divided by 2 root x is equal to dt divided by dx, and the dx is equal to twice root of x into dt. Now, substituting these values in the original function, that is the value of dx and the value of root x. What will we get? We get integration of cos of root x is equal to t, so we will write here t divided by root x is equal to t, so we will write here t. Dx is equal to, so here dx is equal to 2 and root of x is equal to t, that is 2t, and dt. So here t and t will be cancelled. This will be twice integral of cos t dt. So as we know that the integration of cos t is sin t, that will twice of sin t plus c, replacing the value of and t, that is root x, so twice sin of root x plus c, integrate e raised to power 2x minus 1 divided by e raised to power 2x plus 1 dx. First of all, we will simplify this question. Now, we will write this question like this, dividing the numerator and the denominator throughout by e raised to power 2x. So e raised to power 2x minus 1 dividing throughout by e raised to power x divided by e raised to power x whole divided by e raised to power 2x plus 1 divided by e raised to power x. What will we get? Integration of e raised to power x minus 1 divided by e raised to power x divided by e raised to power x plus 1 divided by e raised to power x dx. This is equal to integral of e raised to power x minus 1 divided by e raised to power x is equal to e raised to power minus x divided by e raised to power x plus e raised to power minus x dx. Now it is simple. Now it is simple to substitute here, or in other words we can say it is simple here to choose what is the best option to substitute here. Now if we substitute here the denominator, that is e raised to power x plus e raised to power minus x, as we know that the differentiation of e raised to power x is e raised to power x, and the differentiation of e raised to power x is minus times e raised to power x. So the differentiation of this denominator will give me the numerator. So that is the best option for me to choose here e raised to power x plus e raised to power minus x is equal to t. So we will put here e raised to power x plus e raised to power minus x is equal to t. What is the differentiation of e raised to power x is e raised to power x. What the differentiation of e raised to power minus is minus times e raised to power minus x, that is dt divided by dx. The value of dx is equal to dx divided by dt divided by e raised to power x minus times e raised to power minus x. So substituting these values, now here we will keep this as first. So substitute these values in first here, we will get here integral of e raised to power x minus e raised to power minus x divided by t into dx, that is dx is dt divided by e raised to power x minus e raised to power minus x. So this will cancel here, we will get integration of 1 by t dt. As we know that integration of 1 by t is log of modulus of t, so that is equal to log of modulus of t, and the value of the t is e raised to power x plus e raised to power minus x plus c. This will be the integral of the given function. Let us do the last question, that is integrate 3 sin x plus 4 cos x divided by 4 sin x minus 3 cos x. we have to do this question by using substitution method. So as we know that the differentiation of 4 sin x is 4 cos x, and the differentiation of minus 3 cos x is 3 sin x. So this is the simple way. So we have to choose here denominator is equal to t. Thus we will put here 4 sin x minus 3 cos x is equal to t. So the differentiation of 4 sin x is 4 cos x minus 3, and the differentiation of cos x is minus sin x. This will be plus 3 sin x is equal to dt divided by dx, and the value of dx will be dt divided by 4 cos x plus 3 sin x. Substituting these values in the given function, what will we get? Integration of 3 sin x plus 4 cos x divided by t, and the value of dx is dt divided by 4 cos x plus 3 sin x. This will be cancelled here. We will get integration of 1 by t dt, that is integration of 1 by t is again log of modulus of t. This is equal to log of modulus of t plus c, and replacing the value of t, that is log of modulus of t with the value of t is 4 sin x minus 3 cos x plus c. So this will be the integral of this given question. Thank you for today's lecture.